So in order to study structural equation modeling, first we'll need to change data set. So make sure that you have dataset 4 ready to be imported, that you upload it. And once that's done, you put it in your database. I already have mine, so I will get started. But pause the video if you don't have it in R just yet. So now the first step is to do the PCA, right? To get started with our EFA. And so uh, we will do another PCA, this time with data 4, with the variables SAT 1 to 3, true 1 to 3, and loyal 1 to 3. And again, print comp. So, boom, it's in. You can get the summary right there. What does it tell us? It tells us that, oh, this time we have 3 components. Oh, wait a second. Actually, 1, 2, 3, our theory tells us we also have 3 components. Let's look at the scree plot. And this time you see it's a lot easier to read. You see that we have 1 about here. So below, right here, that's only our 3 extracted variables. So in this case, the theory will match the statistics provided by PCA. While we're at it, let's look at the cumulative proportion of variance explained by the model, and we're at 84, so well above 0.5, above 50%. With that in mind, let's go through EFA. Let's remember that we have to load a dplyr package and then create a model called, this time, model 2, so we don't mistake it with the other ones. With data 4, we select the variables, we tell the function factorNal that we have 3 factors and that we want a Promax rotation once again. So when that is done, we can simply look at the results of the model by simply typing model, oh, model 2 and so be it. And so now we're going to run it and we get the extraction. No problem with uniqueness, everything's below 0.6. What about our factors? This is well below the threshold of 0.2, so we don't have a problem with cross-loadings. No cross-loading here, no cross-loading there. No cross-loading there either. So now let's look at the loading. All of the SATs, they load under factor 3. All of the true under factor 2. You can disregard this one, right? Because it's a low loading. And loyalty, well, that's all of factor 1. So perfect. It's looking great. Now, if you looked at factor correlation, yeah, we are a little bit high here. Well, you know what? We're going to have to call it okay because we cannot reduce the model further. And that's okay. Sometimes you find some limitation with the extraction. You simply report the limitation. Say, well, you know, in the factor correlation matrix, it was a little bit high for the correlation between factor 1 and factor 3. Anyway, then we can proceed to the CFA, okay? And in order to see the results of CFA, we will use a summary function. So since I did not run it, I'm going to do everything at once. All right, here we have test and degrees of freedoms, okay? Excuse me, test statistics and degrees of freedom right here. So looking good. We have the CFI and TLI looking very good, above 0.95. RMC is below 0.1. SRMR below 0.09, so we're all doing pretty great there. The estimates, standardized estimates. Okay, good. All right, that seems very good so far. Let's visualize now. We already installed SEMplot to do that, so we don't have to reinstall it, we just run it. And here it is. Okay, here are the results without the standardized loading here, which is fine. You know how to add them. You would have to use um, simply, where is it? I'm going to copy and paste, that's easier. The what labels std. Up. So you see, if I want it up with the labels, I simply add this, and you see this time the labels appear. All right, that was our review. Now let's talk a little bit about what's new. So what matters here for the SEM is that we define the causal relationships, okay? And so, oops, my code is a little bit altered because I copied and pasted it in a Word doc, so it slightly changes the code. So let me align everything so it looks neat. Here we go. Beautiful. So now we find the same code as a CFA. I copied and pasted it, to be honest. But in addition, we have satisfaction is influenced by loyalty and trust is that should be the opposite. I don't know why it's appear that way. Loyalty is influenced by satisfaction, and loyalty is influenced by trust. Okay, so that's our model. Then, so you see, very similar to CFA. So I just changed the name. Instead of CFA, now it's called SEM. Okay. So now we have the model. We need to look if the data fits the model. Okay. So we do it very similarly. Okay. And this time, though, even though we still use the CFA function, it will CFA is a type of structural equation model. Okay, so it works. Model 2 SEM fit, not the CFA fit though. That's very tricky. You want to make sure you don't mess this one up. I will highlight everything because I didn't run it. Here we go. And this time, it looks very similar. You see, we have the statistics, the degree of freedom. So again, you divide the first by the second. That gives you something slightly below 4. The CFI and TLI looks excellent. The SMR looks great. The RMC looks great. Now we can see the estimate and the standard estimates as we did for CFA, except that we have this regression box here that's new. Loyalty being defined by or regressed by or influenced by satisfaction and trust. And then here you can really, use those estimates to do the equation, okay? Except that this one is not actually significant here. So be aware of this. Anyway, for example, it's probably good enough. So let's conclude by visualizing the model. Same thing, we will use SEMplot. The function SEM passes. And this time for the model, make sure that you select not CFA fit, but SEM fit, okay? We use the what label because we would like to look at the standard values, okay? And doing so, ta-da, we can see our plotted graph with the causal relationships between satisfaction, loyalty, and trust and loyalty. All right, that's it for now.